don't do that. Because once you have a lot of builds that go through your integration server, you're going to have like 17 million emails. You are never going to want to search through those. What's going to happen when you have that is you'll see, oh, my build is done. You'll look and see success, fail. You'll go through and you'll do some other tests to see why it succeeded or failed, probably. And you're basically just giving up on most of the advantage of having some kind of integration testing. Also, nobody wants to get that many emails. It's just not a good way to live. I want to show you a demo of a piece of software called Logstash. The way that Logstash works is you can send integrated integration test logs to Logstash, from pretty much any integration, like continuous integration server that's modern. It'll take stuff from Travis, it'll take stuff from Jenkins, it'll probably take stuff from the other thing of your choice. And it's basically just a really fancy, awesome log server. This is the Logstash implementation that works for an open source group called OpenStack. I'm sorry if that's hard to read. Let me see if I can make it a little bit bigger. And let me see whether making it bigger actually helps. The interface is now a little bit difficult to deal with because I have some scaling effects, but hopefully it's at least easier to see what's going on. So something like this gives you a filter. I'm going to clear out the filter, and it's basically just showing me every single message that any of the integration servers running for OpenStack generated, which is useless. Like, you would never look at this. So what you would want to do is do some sort of series of searches to see, for example, in the branch that I care about, because I'm working on hierarchical multi-tenancy, how are the builds going in there? So I can click on that. It'll highlight. I'll get only those events. Sorry, that's really hard to use, so I'm going to make it small again. I apologize. You can do filters that do more intelligent things. Like, for example, you can look for messages that are error messages and not warnings. You can combine these checks. You can pipe them to other things that like to know how to make graphs. So you can ask questions like, show me messages, show me like series of builds where the message was null pointer exception and the class was my totally awesome class. Like, how many times when I send my build to the server is there a null pointer exception in this class? And that can give you information about, like, well, maybe someone who's working on this needs a tutorial on what null is. Maybe we're using an underlying library that's really hard to work with and it doesn't like nicely throw exceptions and just likes to randomly return null in ways that are unhelpful to you. You can figure out whether you have problems like this, and because there is, I'm going to throw a quick shout out to another tool called Graphite, which is a graphing engine that will take anything in, including these log messages. You can make things that managers love, graphs, about what's going wrong with stuff. So you can make graphs of like how many failed builds happen like during hackathons versus normal development days, if you want to make a point about how you're not really getting any quality code when everyone's sitting around drunk. You can slice this by branch if you want to make points about certain kinds of features being difficult to implement, and that's why it's taking a long time. You can imagine making all kinds of arguments with this data once you can easily slice and dice it, and you're not just sitting with 17,000 things in your email that there's nothing you can do with. In terms of actually setting this up, the documentation for Logstash is good for an open source project. I would recommend if you're looking to do something, I would recommend if you're looking to do it for a small project and you don't want to spend a whole ton of time figuring out how to set up databases and do a whole bunch of sysadmin type work looking for a hosted solution. There isn't really like an amazingly slick, awesome, free good one that I know of, like I know of for Travis. If I find out about one, or if you know about one, I'll put it in the resources. Graphite is the name of the other thing that I was mentioning. They don't have a nice thing where you can just like interact with it, and I don't have a Graphite installation, so I can't give you a nice demo. But it is widely well regarded for making nice visual representations of this sort of information. So I'm going to flip back to my slides. That's pretty much it for what I had for content. So if you have questions or comments, I'd really love to hear them. Okay.
Actually, I have a question. Maybe this isn't to do with testing as much as, you know, you build in all your exception handlers. Where do you want all your exceptions to, I mean, do you want them to come up as errors? Do you want them to be stored in databases, or?
I think it really depends. It depends really heavily on what you're doing and what you, like, whether there's any possibility for recovery. So the fact that I couldn't touch a database, like, there's nothing I can do with that if there's only one database, right? Like, there's just no data available to me. I can make a nicer error message for the user than just, like, whatever exception got, like, a stack trace and whatever got thrown up the stack. And that might be what I want to do with that, but that's really the limit of things that I can practically do with that information. If there's some possibility for recovery, that's when I usually like to use error types rather than exceptions, because you might actually be able to take some other path down your code that's less preferable, but will still be able to deliver some kind of consistency of performance. Did that answer your question?
Yeah, I had different people focus on different things and spent time building complicated exception handling processes.
Sure. Yeah, and there are certainly plenty of times where you're told to implement a whole bunch of exception handlers, and it's basically just catch the exception and throw another exception, and you're like, well, that was a good use of my time on this earth. I don't think that's really necessary. Anything else?
So I remember hearing about fuzz testing before and thinking it was really cool. Do you think that these things would, some of these automated random generation tools replace that, or is it still something useful? And I guess maybe
sounds like the resiliency one to me.
Yeah. So I consider them to be an integration test, basically because it's really like a black. So okay, let me back up and define fuzz testing. Thank you. Fuzz testing is sort of related to generative testing, except it's something that you do to all of your code. So you have some built object. It's perhaps a binary, it's perhaps a virtual machine, whatever. And you know that you have some way of getting data into this thing. And what you do is you just send it a whole bunch of random data. Maybe it's structured random data, maybe it's totally random data. And you see basically if it falls over. You can try to do more complicated things with that, but that's the base level definition. I consider that to be a subset of integration testing. You could certainly do that in something like Travis. You would just have to write the script for it. It's a little bit more complicated if you want to do things like network stack testing, because Travis doesn't nicely support, like, I have one socket and I want to send to another socket. It'll do things like set up a database for you, but it's a little, there's not like good threading or anything in there, so you're going to have a bad time. I don't know whether Jenkins does better with that. I promise, so I set a personal challenge for myself to give a whole talk on testing without talking about security, because I'm a security person by trade. And I think most people are not really super interested in talking about that. But I will say, since I have a little bit of extra time, a lot of this stuff gets you really good security benefits too. Because most of the security problems that you have are related to input validation. So when you're thinking about what kind of bad data you can get, you're already like way up ahead on dealing with potential security problems that might come down the pipe.
Great.
All right.
Thanks.
Thanks for your time, everybody.